Hey class, this is the second part of single displacement reactions, sheet number 6, where the first two parts, A and B, were a metal and an salt, and metal and an acid, and this one's metal and a water. Now, as it turns out, the only thing that works for a metal and a water is the activity series 1 through 6, so the most reactive metals, 1 through 6 on the activity series, which looks like this. Most reactive are these that react with water. So something like this plus H2O are the only ones that react, and these down here are, of course, a no reaction. So that means that magnesium is not reactive enough to react with water. So let's go back to our example. So when I take a look at this, it says if the metals are from 1 to 6 in the activity series, cold water reacts with cold water to liberate. That means as a product hydrogen gas and to form the metal hydroxide. Okay, so that means hydrogen gas and the metal hydroxide. The metal hydroxide is a -1 for hydroxide. So here's what I do to make sure that I'm always, it's easier for me to see that hydrogen is taken like out of water by strontium. So we're following our A plus B, C pattern again, except here I've rewritten H2O to make it look like the B is the H plus and the C is the OH minus. And that helps to show that strontium kicks out the first hydrogen, hydrogen with the +1, and goes with the hydroxide. So if I do that on the other side here, oh, by the way, strontium is number 4 on the list, which means that it's between 1 and 6, or within 1 through 6. So now strontium is in the second group, which means it has a +2. If hydroxide's a -1, that means over here I'm going to need 2 of them. Then that 2 comes down for crisscross. And then we have hydrogen. Notice that hydrogen is Brinkelhoff, so I have to do the 2 for hydrogen there. So now I get rid of all this stuff here. I can keep the HOH like this, but now I look to see if I'm balanced, and I have 1 SR, 1 SR, 2 hydrogens. I only have 1 hydrogen here, and I have 2 OHs, and I only have 1 OH here. So that means that I put a 2 in front. That gives me 2 hydrogens and 2 OHs. So that works. So it's a 1, 2, 1, 1. So that's how we do. Let me get rid of the charge here. And that's how we do a single displacement with metal and a water. Now, take a look at cobalt. Cobalt is number 14 right here, and then no reaction zone. So 14 does not work. That means this is very easily a no reaction. Now take a look at letter D. Letter D is a little bit different. Letter D is when we have a nonmetal. Okay? As a matter of fact, all halogens are nonmetals. So if it's a nonmetal and a halogen salt, means that, well, first of all, what's a halogen? A halogen, starting with, is a group, specific group, starting with fluorine. So it's fluorine, chlorine, bromine, iodine, and acetine. AT, bonehead, like that. Just like for the metals for the activity series, lithium at the top of the list was the most reactive. Fluorine here is the most reactive. So this works exactly like the activity series, except this is like an activity series just for nonmetals. And so fluorine is the most reactive, so fluorine can kick out chlorine, but chlorine can't kick out fluorine. Or fluorine can kick out bromide, but bromide can't kick out fluorine or chlorine. So halogens will displace the less reactive halogen. The most reactive halogens are at the top of the periodic table, which is what I have written over there on the side. So this is now A plus BC, except this, in this case, we have a nonmetal, so this is our anionic single displacement, and the anion is the negative part of the compound, which means that the A replaces the C and kicks C out of the compound, which means Ba plus C is on this side now. So B is plus, that's a cation, stays a cation, and gets replaced, C gets replaced with A. Okay, so it looks something like that. So take a look. I take a look at chlorine here. Chlorine is right here, and it can replace any of these below it like that, which iodine is the one that's below it, so that one's in the compound, so it looks like chlorine is going to kick out iodine. So that means I got Na as a positive, I got Cl as a negative, and then plus iodine like that. Okay? Now on the other side, I get rid of the charges. I get NaCl. Of course, when I do my crisscross, I just get NaCl plus iodine, but what do we know about iodine? Don't forget about Brinkelhoff, because he hasn't forgotten about you. So that means that iodine here needs a 2. And then I go back and I balance the number of 2's for iodine 2 and iodine 2 there. That gives me 2 NAs, which means I need 2 NAs on the right-hand side, which also means I had 2 chlorines, and I already have 2 chlorines. Okay, so I need a little bit more room at the bottom, so I move this down like that. Bromine. Bromine is right here. Hang on, let me erase this. Is right here, and it's saying that it's going to try and kick out chlorine. You can't kick out a more reactive non-metal, so this is simply a case that does not work. And you can look on the periodic table to see what order they come in. Okay, so bromine cannot kick out chlorine from that compound, so that is a no reaction. All right, let's do a couple examples. So the first one here for number 1, letter A, zinc and an acid. So this is this would be letter B notes, metal plus acid. That's what we have here, metal plus acid. How do I know it's an acid? Because there's an H in front. So what is the metal? The metal is zinc. Zinc is, where's zinc? Zinc is right here at number 10, which means 10, hydrogen's always 18. This definitely works. Lower number replaces the higher number. So that means zinc is a plus 2. SO4 is a minus 2, like that, plus, and then hydrogen. Now this 2 is not here because of this 2. This 2 is here because of crisscross. Okay, that 2 is there because of crisscross. What we take over to this side is H plus, okay, but because we get rid of the plus when hydrogen's by itself here, this 2 is here because, of Brinkelhoff. Okay, so the 2's, I know the 2's look the same, but they're not. They're not the same. That 2 is there for crisscross, this 2 is here for Brinkelhoff. I go back to check to see. 1 zinc, 2 hydrogens, 1 SO4, or there would be parentheses, and 1 SO4. So we're in good shape. That's already balanced. Make sure that you balance the equations at the end. Okay, let's do another one. How about the letter B? Now this is just a metal plus a salt. So I have aluminum. Aluminum's number 8. Copper is number 22. So this one is going to work, okay, because the smaller number versus the bigger number. So I got aluminum here with a plus 3. I put aluminum kicks out copper and goes with sulfate. Sulfate is SO4, still a minus 2, just like it was before. Copper's by itself, like that. Okay, and because copper is by itself, we don't need a charge for copper, so we just let that go. Now I need to crisscross. The crisscross goes 3 comes down. I need parentheses and a 3, and then the 2 comes down, so Al2, SO4, 3. And I got rid of the charges like that. Now I have to balance. So that means that if I have 2 aluminums on the right-hand side, I need 2 on the left-hand side. I have only 1 SO4 here, but I have 3 on the right-hand side. So I put a 3 in front of the whole compound, which means I now have 3 coppers. So I need 3 coppers there. So 2, 3, 1, 3. All right. Let's take a look at some examples of the ones that are written. Like this one, sodium plus water. Well, we have to write out the formulas first before we can do this one. You can't just put an arrow here and then write the products because it's very difficult to balance the equation if you don't have the symbols written. So we do sodium Na, it is not Brinkelhoff, so there is no 2, plus water. Water is a common name for the formula H2O. Of course you know that. Good God, I hope. But you know what I'd like to do? When I have water here, I'm going to write it, not the same, HOH. And I do that to show that sodium, if sodium is between 1 and 6, can kick out hydrogen. And it kicks out hydrogen there because of notes letter C, where it's metal plus water. So I need to check to see if sodium is between 1 and 6 on the activity series. And if it is, then sodium kicks that hydrogen out and goes with OH. So let's take a look. Between 1 and 6, sodium is number 6, so it does work. Sodium does react with water. So sodium kicks out the hydrogen by itself to look like this. Remember Brinkelhoff. And sodium is a +1. Hydroxide is a -1. I'm hoping you're starting to learn the polyatomic ions. And because it's a +1 and -1, the crisscross looks like that. And then all I have to do then is balance the equation. Now, when I kick that 1 hydrogen out and I put a 2 here for Brinkelhoff, that means that I need 2 hydrogens. I don't have 2 hydrogens on the left-hand side. I have 1 hydrogen and 1 OH, or hydroxide. So I put a 2 in front to give me 2 hydrogens and 2 OHs, but that means I need a 2 in front of here to give me 2 sodiums and 2 OHs, which means I need to put a 2 in front of here to give me 2 NAs, or 2 sodiums. So 2, 2, 2, 1. And that should do it. Let's do another one. How about, let's see, A, B, C, D, E. Let's do D. Take a look at this one. This is aluminum plus nitric acid. Okay, aluminum's not difficult. That's just Al. There's no charge with that because it's by itself. Nitric acid means nitrate. Okay, nitrate is NO3 with a -1. Acid means H plus with a +1. When we crisscross, we just get HNO3. That's how I do the acids. And then there's my arrow. Now I need to check to see if aluminum is lower than the number 18 for hydrogen. So hydrogen is number 18 on my, there it is, activity series. There's hydrogen, that's for all acids. And aluminum is number 8 here. So that means that aluminum works. Kicks out, there's 8 and 18. So aluminum is a +3, and that goes with the negative part, which is NO3, which is a -1, like this. And then hydrogen is by itself like that. The 3 comes down. I need parentheses and a 3. And then I get rid of this. Because that's a -1, I don't have to put the 1 down for aluminum. Now I have to balance. Because I have 3 nitrates on this side, I need a 3 there. That gives me 3. Uh-oh, we've got a problem. Houston, we've got a problem. I'm going to have to double this one so that I have 2 aluminums and 2 aluminums. And the reason why I did that was to double the number of nitrates, which will give us then total of 6. So I need 6 nitrates here. That gives me an even number of hydrogens, because before I had 3 hydrogens, but I need an even number because of that 2. So now if I put a 3 in front there, 3 times 2 is 6 hydrogens, and here I have 6 hydrogens and 6 nitrates. So we should be all balanced. 2 aluminums, 2 aluminums, 6 hydrogens, 3 times 2 is 6 hydrogens, and 6 times 1 is 6 nitrates, and 2 times 3 is 6 nitrates. So that should do it. All right. Work on those yourself. Please ask questions. We'll have a Zoom at some point so that you can ask questions about all of this stuff. That would be great, and we'll talk to you later.